Good morning, friends. My name is Mr. A.D. Patil. Today we will discuss about the sign convention to solve the Sfd and Bmd problem. Now selected beam is a cantilever beam. So cantilever beam, the main point is to understand the position of the support. Look at the two diagrams of the simply supported beam. So upper one diagram, the support is at the right side of the beam, and in second diagram support will be the at the left hand side of the beam. So as per that, sign convention will be changed in the BMD only. Okay, sign convention for the SFD will be the same. So only one support is there at point A, here also is at point A. So one support is there, means there only one reaction will be generated, uh, which is at point A, and which is RA. Here also same RA. So first we will understand that this cantilever beam, which have the left side support. So to find out the RA, we have to use the analytical condition summation of f of y equal to 0, and upward going forces will be the positive and downward going forces will be the negative. To calculate the SFD, we have to use the same sign convention. The forces going upward is positive and going downward will be the negative. So we have to move from the point left hand support, sorry, left hand point to the right hand point, means from the A point to the C point to the D point and to the B point. So so how to write the name sequence for to calculate the SFD? So shear force at the at point A, shear force at point C. Okay, now look at the diagram. The UDL started at point D and ends at the B. So whenever UDL starts, use concept of left and right whenever the UDL start. Means suppose at point D UDL start, use the left and right, means like this: shear force at the left of the D and shear force at the right of the D, because UDL started, and UDL ends at the B, means shear force at left of B and shear force at right of B. So left and right concept will be used only for the UDL portion. Okay, uh, only UDL portion. If in beam there will be no UDL, then use the simple sequence as I already told in the simply supported beam and the overhang beam. Okay, so shear force at A means what? We will count the forces up to point A only. Okay, whatever in right side we will not consider. Shear force at C means we will consider the forces up to point C only. Okay, whatever at right side we will not consider. Left shear force at left of D. Left of D means where? Here, left of D. Up to the dotted line we will consider the forces. Okay, except at left of D means we will consider the forces up to the dotted line only, left of D. And what is here? Shear force at right of D, means right of D means here. We will consider the forces up to point D. Okay, kindly understand the difference between the left and right. Same here, shear force shear force at left of B. Left of B means here. Look at the dotted line at the B point. Left of B means up to this point we will consider the shear force, shear forces up to the left of B, and right of B means here, right of B. up to that point we will consider the forces. Okay, like this we have to calculate the forces. Shear force diagram is related only about the forces. Okay, forces, force going upward means take the positive, force going downward take the negative. So here only we have to convert the UDL into the point load. Okay, how to convert we will see in the numericals. Okay, so here, these are the reference point A, C, D and B. Do not create the extra key points. Use uh, given key points. Okay, means four key points are given or four reference point given. Use only that. Do not create any other key points or reference point. Okay, next will be the BMD. For BMD, we have to move from right hand to the left hand. We have to move from the right hand right hand to the left hand. So look at the sequence to write the names: BM at B, BM at B, BM at D, BM at C and BM at A. Look at the sign convention. BM at B means we will consider or we will count the forces up to point, we will calculate the moment up to point B. BM at D means we will calculate the moment up to point D. BM at C, we will calculate the moment up to point C. BM at A means we will calculate the BM at A means we will calculate the moment up to point A. Oh, okay. This left and right concept is only between the only we use in SFD calculation, not for the BMD calculations. Okay, again, moment definition is or formula: moment equal to force into perpendicular distance. Here, clockwise moment will be considered as negative. This is a change, and anti-clockwise moment will be considered as a positive. Okay, this uh, here only change between the BMD calculation due to the this support. Okay, so consider this changes while calculating the BMD. Okay, next will be the this position of the cantilever beam. So in this same sign convention, we will use that are previously like the in orang and the simply supported beam we have used. Like here is also one support is there. There will be the reaction RA will be generated. So one unknown is there. So one analytical condition we have to reach. Upward going forces will be the positive and downward going forces will be the negative. So to calculate the SFD, sign convention will be upward going forces positive and downward going forces negative. So in SFD, we have to move from the left to right, means SF at C, SF at B and SF at A. In this cantilever, there will be no UDL. So we have write the name sequence SF at C, SF at B and SF at A. Okay. In BMD, we have to move from the left to the right. Okay, here will be no sign convention or move from the left to right will is not change. Okay, so clockwise will be the positive and anti-clockwise will be the negative. Definition of moment equal to force into perpendicular distance. So look at the left to right. Left to right means BM at C, BM at B and BM at E. So only sign convention is change in this position and only for the BMD. So sign conventions are opposite whatever we are using previously. Okay, in cantilever only for this position. Okay, and this concept of left and right kindly understand for the UDL only, and starting point and to the ending point we have to use the left and right concept. Okay, in detail we will see in the numericals. Okay, thank you very much.